Welcome, and thank you for joining us for the Supermarket News webinar, Retailers and Refrigerant Regulations, with our sponsor and presenter, Chemours. I'm Mike Brown, Executive Editor of Supermarket News. Today, experts from Chemours are on hand to talk about refrigerant solutions and the current regulatory landscape. During this session, we'll walk retail food operators through how federal regulations to phase down HFC refrigerants and state regulations limiting refrigerant options will impact your business and what products are available to support your needs. In today's session, the Chemours team will provide a comprehensive overview of economically sustainable solutions that are currently in use, as well as up-and-coming refrigerant technologies that are available to support the needs of tomorrow. Just a note before we begin, there will be a question and answer period at the end of the presentation. So if you have any questions, please feel free to enter those into the Q&A chat field on your screen. If at any time you experience difficulties with the audio or advancing the slides, please refresh your console. With that, I'd like to introduce our speakers for today's webinar. We have Brandon Marshall, North America Marketing Manager for Chemours, Mitch Newsome, Market Development Consultant, Retail Refrigeration, and Andrew Pansulla, Global Technical Service Engineer, Refrigerants. Welcome, gentlemen. And we'll begin with Brandon.
Yeah, thank you very much, Michael, and thank you very much for having us back again. And hello to the audience, and thank you for joining our webinar today. We got quite a packed agenda, so we're going to jump right in. So we'll kick off briefly here with a little bit of a background on Chemours and who we are and what we're about. We'll then jump into a regulatory update to provide you with some information from what's been going on both at the state and the federal level over the last several months since we last met, and ensure that you have the most up-to-date information. From there, Mitch Newsome is going to jump on, and he's going to work through retrofit solutions that we have available today, as well as new equipment solutions to help support your needs as we go through the next big refrigerant transition. Then Andrew Pansulla is going to jump on, and he's going to walk you through our next generation solutions and what that's going to look like based on the experience that we've been able to build in Europe. It'll come back to me at the end. We'll take a look at some tools as well as some documents and other information that's available to you. Number one, that you can use internally. And number two, as you're thinking about your future plans, to use as a reference point to be able to jump into some of these regulations and jump into some of the products so that you have a clear understanding as to what's coming and why. So we'll start off quick with Chemours. If you're not familiar with our company, we are formerly DuPont, so we spun off from DuPont in 2015. We're headquartered right in Wilmington, Delaware. We have about 7,000 employees on the books today. We operate globally with 3,700 companies. And as it pertains to refrigerants, we're most well known for Freon. That's been the long-standing 90-year brand in the market. And also next generation low GWP Opteon refrigerants. So as it pertains to regulations, when we were on here a couple months ago with Michael and the rest of the team here from Supermarket News and Chemours, we really talked a lot about CARB and we talked a little bit about AIM. Today, we're going to provide just a brief update on both of those regulations. As some of you may know, the AIM Act has now been implemented and we will be starting the phase down of HFCs in the U.S. market starting January 1st, 2022. So we want to provide some information as to what you can expect as we approach that, as well as what's coming next. Looking at the landscape, for many of us, we've always looked at these charts. We get a lot of industry updates. Phased down for several years. When you look at Europe, when you look at Canada, they've been operating under Kigali, which is phasing down HFCs in their regions. We've all been operating under Montreal Protocol, which was the phase out of products like R22. Over the last several years, we've seen some changes. So in the absence of federal activity, the states really began starting to regulate, really with the U.S. Climate Alliance. And we saw a lot of activity around CARB and how CARB was going to regulate HFCs in the future, namely around refrigeration and HVAC. One of the big benefits when we look at what's coming with AIM is that federal presence is starting to step back in, right? I know for a lot of us on the line here, there's always trying to understand what's happening between the 50 different states that we serve can be convoluted, and having a path forward at a federal level that we can all look at and follow is beneficial. So with new federal regulations and with the AIM Act now being passed and on the books, this should help to realign our industry and give a clear path forward, not only for OEMs and manufacturers like ourselves, but also for end users, contractors, and distributors. So when we look at California, there's a couple key points that we want to note here. There are several rules inside of the California rulemaking. However, we're going to focus on the ones that pertain to retailers. So first and foremost, inside of the HFC rulemaking, it requires that retailers operating chains inside of the state of California meet an average chain GWP of 1,400 or less, or show a 55% reduction in GHG below 2019 levels by the year 2030. Depending on the size of the chain that you're operating today, you may have some different requirements in terms of when you're reporting. So for those chains operating 20 or less stores, you have a check-in in 2026. And for those chains operating more than 20 stores, you have a check-in in 2025. Now, on top of the actual rulemaking around the average chain GWP or 55% reduction in GHG, you also have some other regulations impacting the type of equipment that you can use. So starting January 1st, 2022, for any system newly installed with more than 50 pounds of charge, you'll be required to use a working fluid of less than 150 GWP. Okay, so this is an important point if you're looking at larger systems like centralized racks versus less than 50 pounds, where you have more options and flexibility to work within a 1,400 GWP mark. So if you are operating stores in California today, we'll talk about some tools that we've made available to the marketplace towards the end here. But as you have questions, please feel free to enter them into the chat. And more than happy to address any specific points for your business that you may be concerned about, especially if this is the first time that you're hearing about it. Now, when we think about the AIM Act, back in December, a lot of companies started communicating with the marketplace, including Chemours, that the AIM Act was passed, and that happened on December 27, 2020. Okay. That document was contained inside the U.S. Omnibus, so it was passed very quickly at the last hour, and industry started to communicate around potential impacts. When you look at the AIM Act, it enables the EPA to manage HFCs in three different ways. Number one, it allows them to establish a national CO2 equivalent baseline and issue allowances to producers and importers of HFCs, very similar to what we saw with R22 under the Montreal Protocol. It also enables the EPA to create sector-specific control, i.e. GWP limits like we've seen in the past during the CARB rulemaking. And it also enables the EPA to strengthen HFC reclamation guidelines. The first part of the rulemaking was passed and signed by the EPA administrator on September 23rd and entered into the Federal Register on October 5th. And this first part of the rulemaking addresses specifically that first point, a national CO2 equivalent baseline and issuing allocations to suppliers. So effectively, the phase down of HFCs will begin on January 1st, 2022, and allocations have been issued to the producers and importers for 2022 and 2023. There are a couple important notes around this. Number one, the price and availability, especially of higher GWP products, could change as we progress through the phase down, right? A lot of us are seeing what's happening with R22 in the marketplace, right? This has been a product that was phased out several years ago. No new manufacturing or production starting on January 1st, 2020. And we can expect to see something very similar as we talk about HFCs. There's going to be significant changes coming to packaging and labeling, okay, and that's going to hit in 2025. So right now, the EPA has authorized the elimination of DACs, so disposable 30-pound cylinders that are used in the market today. And Chemours, as well as other partners in the industry, will be looking to use refillable cylinders. As industry updates, we have gone through this in Canada before. If you've worked in Canada or if you're operating in Canada today, refillable cylinders are the standard. So this is nothing new for our industry, broadly speaking. It's just new for the U.S. market. A common question we've received is, are small cylinders still going to be available, or do I only have to work with tall cylinders now? And happy to report that there are options for small cylinders. When you look at the phase down schedule here, there is one important note that I wanted to highlight as we move through this, okay? And that's really around all of us having to work together to ensure for an orderly phase down. I hear a lot of comments about, what happened in Europe, what happened in other parts of the world. And from our view, we have an opportunity now as an industry, as contractors, manufacturers, and end users, to all work together to reduce the demand of those higher GWP HFCs like 404A and move to lower GWP options that we'll be exploring here in a few slides. So when you think about what's coming next, as I noted before, the allocation program for production and consumption was completed in 2021, and we expect that the EPA is going to begin addressing publicly sector control limits in 2022 and looking for feedback from industry, as well as understanding what the U.S. reclaim program is going to look like long term. As with any rulemaking, the EPA is going to have public stakeholder sessions, and they'll be looking to hear your voice about what makes sense for you and your business. So keep these dates in mind as we continue to move through. So with that, I'm going to hand off the ball here to Mitch Newsome to go through some retrofit solutions. So Mitch, are you able to jump on?
I am. Thanks, Brandon. So as Brandon alluded to, I'll be discussing refrigerant conversions. Obviously, there's a lot of infrastructure in place here today that is utilizing these higher GWP refrigerants. So I'm going to go over some factors affecting decisions around refrigerant conversions for organizations. Then I'll jump into kind of the steps that it takes to do a gas conversion for a supermarket. And then I'll end with a few products that Chemours offer here today that are good replacements for the existing systems that are utilizing these higher GWP refrigerants. Oh, excuse me, go back one. So as I just referenced, refrigerant conversion factors, there's a lot of factors today that are affecting decisions for organizations. These are a few of them that we kind of want to highlight. Brandon kind of touched on this previous slides, but the future high GWP HFC availability and price is predicted to change as we go through this HFC phase down, as well as long-term compliance has to be considered. Brandon touched about all the regulations and all the conversations going on about HFCs. So as organizations look to make decisions to get away from these high GWP HFCs, they have to consider these factors. Secondly, useful life of the current system. This is a system 20 to 30 years old, running kind of on its last leg, and you may want to consider looking at some of the alternative architectures or next-gen refrigerants that Andrew will touch on next, or is it a 5 to 10-year-old system that's being maintained and serviced correctly, has a lot of useful life left, where you can utilize maybe some of these lower GW refrigerants. Those are just another factor that goes into any kind of decision around refrigerant conversions. Thirdly, skilled labor availability. And I'll also add skills to this. I think it's no secret in our industry that skilled labor can be hard to find, especially if you're working with a contractor. You don't have your own internal labor. Summer months, they may be a little busier than during the winter months. Might be hard to get them to your remote locations. What their capabilities are on servicing certain types of architectures and equipment might go into factor in your decision process. Then fourthly, supply chain and inflation. I think these are big buzzwords going on right now in the market. If you're paying attention, not only supply chain for stocking your shelves at your grocery store, but supply chain for equipment and your facility management. I know I was talking to a contractor the other day, and equipment that was usually 6 to 8 weeks lead time, usually very accessible equipment, was 20 weeks lead time. So it just factors into decisions as stores look at remodels and look at doing things for the next year or so, as well as inflation. There's grocery stores operate on low margins. We were seeing crazy inflation. I think it was just reported that it's up 6% last month in October. It usually is 1%, 2% increase. So again, those go into factors or decisions when looking forward. And then I'll end with operational goals and organizational planning. Obviously, any organization or all organizations have their own goals and planning and prioritizing. Is it easier to service or maintain the equipment? What's our long-term goals with that store? Are we going to keep it open? Are we going to expand it? So just communicating and making plans as a team internally kind of go into any kind of decision. Okay. Next, I'll kind of go through the conversion factor. Let's say you are, conversion steps. Let's say you decided to do a conversion at one of your stores or multiple stores. What's that process kind of look like? And I'm going to go through this very high level. But first, it needs to start with a site survey. You need to get your technicians internally or your contractor out on site recording baseline data. So they're going to be hooking up gauges. They're going to be going through that building automation system. They'll be kind of getting performance data with that current refrigerant in the system, check for correct charges and operating conditions, all that good stuff. Get the model and serial numbers off the compressors, the condensers, just due to the fact that things change. And a lot of times you can get that data from as-built drawings, but as a lot of us know, those are sometimes hard to find, not handy, or there's been updates or changes to those original drawings. So have the technician or if you go through the system, get all that baseline data, get the current infrastructure in place, and go through that. And then you're going to want to set up a call with your technicians and your engineering firm or your internal engineers to kind of review what they see on site with what you are planning to do moving forward. Quick on the trigger with that. Step 2, you're going to do some work preparation. So you've had that call with your team. You figured out what you want to do moving forward, and what's it going to take to convert that system to a new gas. So you're going to have store coordination. Is it going to be after hours? Is it going to be during hours? Is there certain things that you're going to have to do with product during the meantime for this change out of refrigerant? You also want to obviously review the scope, verify that you've done your checks and balances. You're not missing anything. That if everything's done, called out in the scope, that you're going to have a successful project. Then you're going to order all the parts and refrigerant, make sure that's all going to be on site and be there for when the job is performed. And any kind of job or any kind of project like this, you want to have a project management plan in place, someone kind of leading the charge and making sure everything goes as needed. Stop doing that, I promise, at some point. Step 3, the actual conversion. The day of the retrofit, you want to make sure you've already had everything prepared from the last step. You want to remind your store personnel that you'll be doing the retrofit, secure that food, perform all the items on that checklist, evacuate the system, check for leaks, replace filter dryers, do all that good stuff that you're calling out on that scope of work. Then you want to commission that system, start up that system, and do a project closeout. So at a very high level, that's kind of the steps to doing a conversion. So what do the success factors look like? So hopefully you've had a successful project and conversion, and these are the things that you come away with. Hopefully you can reduce leaks through that flushing of the system of the old refrigerant and putting in that new refrigerant. You've identified any weak spots in the system, any leaks. I think we can all agree that supermarkets can do a better job reducing leaks. Seems like supermarkets leak a lot more of their systems than other systems. So reducing those leaks is a big ticket item, and I know a lot of people do focus on that or are trying to do that. So hopefully you come away with reduced leaks, and you should when you do a gas conversion. Also, reduced energy. A lot of these refrigerants will provide an energy benefit, but also with recommissioning the system, which a lot of systems kind of fall out of how they should or how they were designed to operate. So with these converting to a more energy efficient refrigerant, as well as kind of recommissioning the system, it should hopefully reduce your energy spend. And then you've also upgraded your system for the long term. You don't have to rip and replace the whole system. You got a new lower GWP refrigerant in that system, and hopefully you can have that system in place for a while. And then lastly, better food quality. Hopefully you have a bit more uptime of that system. You don't have big temperature swings. You're keeping that food cool or frozen within that system, and you just have better food quality. Okay. Lastly, I'll be discussing a few products that we here at Chemours have to offer that are great refrigerants to replace these higher existing GWP refrigerants. One of them is Opteon XP40, known as R449A. It's a great replacement for R22, 404A, 407A, 507A. You kind of name it, anything low and medium temp refrigerant with those kind of refrigerants. That's a good replacement. And then on the medium temp side, XP10, R513A, it's a good replacement for R134A. So here's a kind of high-level highlight of XP40. As you can kind of see here, it's non-ozone depleting. It's got about a GWP of 1397, which is about 67% lower than 404A. It's a safety rating of A1. It can help reduce energy spend up to 12%, get you to extend the life of that equipment, which we talked about earlier, and it's widely available here today. Kind of diving into some of the technical side of things when you're looking at doing this XP40 conversion. If you're going from R22 or 404A, there are a few things that you need to kind of consider and make sure that your technician force or your team considers when they're doing these conversions. And we would just want to highlight a few. But first is the changing the oil. A lot of R22 systems use mineral oil. 404A, you'll find that most of those systems use POE oil, like most HFC and HFO refrigerant systems. But with R22, if it is mineral oil, you're going to have to change to POE oil. And we recommend doing a couple flushes of that system just to make sure there's no residual mineral oil left over. That can cause problems for the system if there is too much residual mineral oil left over. Secondly, the elastomeric seals. Again, here for R22 going to 449A, you're going to want to look to change those critical elastomeric seals, due to the fact that with R22, it makes those elastomeric seals kind of expand and harden. They're pretty harsh on them. So when you go to that 449A refrigerant, those elastomeric seals might be a little loose because they're not as harsh. Those HFO refrigerants aren't as harsh on those elastomeric seals. So that can cause leak points. So it's just better to kind of change those critical elastomeric seals. And then with 404, there's no change really needed because they're like 449A, not very harsh on those. Then the expansion valves, R22 to 449A, those valves should be reusable if properly sized right. You may need to simply just adjust the spring pressure on that TXV, but very minimal adjustments needed. With the 404A to the 449A, it's a little more that needs to be done there. You may look to even completely replace those expansion valves. The spring pressure is going to need to be adjusted similar to the R22 conversion, but you're also going to need to probably change that power element regarding that expansion valve. So you may need to look at changing out those expansion valves. Then with filter dryers, just like any normal maintenance practice, you need to change out those filter dryers, make adjustments maybe to some set points on the controls and compressors. But those are just some high-level overview of some things to really consider when looking at doing some of these conversions. Not to get too much in the weeds on some of this technical data, but this is just kind of more in depth when looking at the performance of R22 compared to XP40 or R449A. You'll see that relative capacity is fairly similar, so it doesn't really have issue meeting those cooling needs. The close efficiency match to R22 as well. A little bit of increase in mass flow. Again, valves may need to be opened up with that spring pressure to hit that target superheat, and just some technical data to show the performance considerations between R22 and XP40. Then XP10, R513A, or 513A, excuse me. Another non-ozone depleting refrigerant. It's got a GWP of 631, so about 56% lower than R134A. It's got no temperature glide. Another one that helps extend the life of that existing equipment, and a Class A1 safety rating. Then here again, some comparison with performance between R134A to XP10. Very similar capacity, actually about a 3% gain compared to 134A. Similar suction pressure, only minor adjustments to the valves really needed. So a good replacement for some medium temp applications using 134A. So that was kind of an overview of the refrigerant conversions that we wanted to do here today. Hopefully that answered some questions you might have when considering conversions. And please don't hesitate to reach out to us if you have any more questions. And at this time, I'm going to pass it over to Andrew to kind of talk about those next generation solutions that we offer here at Chemours.
Great. Thank you, Mitch. And good afternoon, everybody. So Mitch kind of covered the difference between some of the retrofit refrigerants that we're offering, and now we're going to transition to some of the more, I guess, future state of where the refrigerant industry is going. Some of this full disclosure, based on codes and standards and where we are in the regulatory world of the U.S., this is a little out there still, but overall, I think it's important to start looking at these types of alternatives, because as you're designing supermarkets or just trying to figure out long-term what type of architectures you want to work with, these are the type of questions that you need to answer around what refrigerant should I use and which ones are going to be available. Anytime you hear one of the refrigerant presentations from Chemours, you've probably seen this slide, and it really kind of shows the whole timeline of where the refrigerant industry used to be to where we are today. And today, I think it is really a mix of industrial chemicals, such as CO2, hydrocarbons, and then the HFOs and HFO blends. And honestly, there's a lot of factors that go into which one would be the best for your system. But overall, the refrigerants for the future really need to balance that performance, safety, sustainability, and total cost of ownership. And in this section of the webinar, I'm going to present on a study that was done in Europe, where they can currently use A2L refrigerants to really try to see where the A2Ls fit in that balance. If you look at our portfolio, there's a couple of different A2L refrigerants that are applicable for applications that historically have used refrigerants like 22, 404A, 134A, really any of the incumbent HFC refrigerants. There's likely the retrofit gases that Mitch covered, and there's also the very low GWP A2L refrigerants. So products like XL40 or R454A with the GWP at 238 very closely matches the performance of 404A from a capacity and a efficiency basis. And then we have a product called 454C, which has a GWP of less than 150, while also being pretty similar in capacity and energy efficiency to things like 404A. Because we had to design around the 150 number, I'd say on average you would expect roughly about 8 to 10% lower capacity for 454C versus a 454A. But overall, for the less than 150 space, that's going to be one of the higher capacity fluids available in the fluorinated world. For the 134A type gases, you have 513A, which Mitch mentioned, and then you have neat 1234YF. And the interesting thing about that refrigerant specifically is that if you take the AR5 GWP values, it has a GWP of less than 1. So there are some very low GWP HFO solutions available that are coming down the pipe for new and even remodels of supermarkets or anywhere in the commercial refrigeration industry. So one of the questions, and quite honestly, this could be a whole other hour webinar, is what does it truly mean to be an A2L, and what does it mean to be mildly flammable? It's something that is a new term to the industry, and I think it's something the industry is still trying to figure out really how to fully implement through safety codes, standards, all the regular refrigerant industry references. But at a high level, really, if you hear the term mildly flammable, really what it means is that they exhibit lower flame propagation and require much more energy to ignite. So the situations where you can see an A2L create a ignition event are much more confined versus, say, a hydrocarbon. There are studies available that are looking at this to really try to continue to strongly define what does it mean to be an A2L refrigerant. So there's the AHRI final report on the investigation of energy produced potential ignition sources in residential applications. So for this study, they essentially took a bunch of common events that could cause ignition of a flammable refrigerant and tried to cause an event. And all the green ones are ones where, for this study, they didn't see any refrigerant combustion. So things like a hand mixer, cordless drill, friction sparks. So it's definitely a change to the industry, trying to understand the differences between, say, like an A3 and what it means to be mildly flammable. But there are some really, I think, good applications to use these on a total sustainability perspective. When you look at it, so what is being done to ensure the safe use of A2L refrigerants in the industry? Things like charge limits are being looked at. So standards like UL 2-89 are being updated. Leak prevention and detection is another big one. I think you're going to see a lot more energy towards making sure that if you're using an A2L refrigerant, that the proper refrigerant sensors are being installed to make sure that if there is a leak, they can address the leak. Training requirements. So many organizations today are developing training to make sure that contractors and end users know how to safely handle these new refrigerants. Things like cylinder design and disposal is changing, recovery machines. So there's definitely a lot of information coming down the pipe on A2Ls. And I would definitely recommend staying in touch with some of the industry organizations that are putting the training out to make sure that you're getting the latest and greatest information. So I think if you look at it and really based on all that information, you might be asking, why should I go through all the hurdles to use an A2L, right? What is really the value that they can bring? And this is one of the things that was studied by our colleagues in Europe. And really with this study, they presented 7 different refrigerant system designs. So they looked at air-cooled integrals, water-cooled integrals, transcritical CO2, R290 glycol loops, a 134A CO2 cascade, XL20, which is 454C, the GWP less than 150, XL40, which is the 404A lookalike with the GWP slightly above 150, and then also XP40, which much of the world is used to working with today. And they really were trying to quantify how the performance of those refrigerants compare to some of the not-in-kind and also the non-flammable HFO products. So what you're seeing on this chart is really the 10-year life cycle cost. So this is considering things like CapEx, maintenance, and energy usage in 2 different climate zones. So they did a climate zone in Sevilla, Spain, which really the design temps were around 100F for that. And then they did Leicester in the UK, which the design temps for that were around 85F. And you could see overall, if you look at really your biggest expense, and this is going to be one of the main drivers of trying to figure out which refrigerant you should use moving forward, is the energy, especially in warmer climates. So when you're looking at trying to figure out what the best sustainable long-term option for your equipment is on a total carbon emission basis, really the energy is going to be such a huge part of that, as long as energy sources still emit carbon into the atmosphere. So this view here shows the emissions for the standard store format for the different architectures that were studied. And you could see that XL20 and XL40 really based on the energy efficiency of these refrigerants relative to a 449A or some of the air-cooled, water-cooled integrals, it really provides a very strong case that on a cost basis and then also from a total emissions basis, the A2L refrigerants are really going to be a strong, sustainable option to be used in the industry as the codes and standards get upgraded and you can work with these products. It can compete directly against the not-in-kind technology on a total carbon emissions basis and in many cases exceed it. So the other thing, and I mentioned this on the previous slide, is really we're getting to a world where you're not talking about GWPs of 4,000 anymore. We're getting to a world where you're talking about GWPs of essentially 150 or less. So that energy usage really dominates the total emissions for very low GWP technology. I can't really stress that enough, where if you're looking at trying to find an option, there's many different routes you can take. And as you look at the very low GWP options, I think energy usage is going to be the piece of it that needs to be stressed the most to ensure that the the balance between safety, sustainability, performance, really all those long-term questions you need to answer are answered. So this view kind of looks at the total cost versus the GWP of it. And really, technologies nearest the bottom left-hand corner are going to provide the lowest emissions while also factoring in the 10-year cost to run the equipment. So in this study with the European, store format and the European climates, really for the products like XL20 and XL40 really provided a way to get a low-cost, high carbon, or really low-cost, low carbon impact compared to some of the other ones due to the energy performance of these refrigerants. So with that, I will pass it back off to Brandon to talk about some of the case histories, applications, tools, and support.
Thank you very much, Andrew. I appreciate it. All right, so a couple of key points off of the presentation that you've seen here today before we jump into the tools. So number one, regulations are in place to drive the use of lower global warming potential products. Okay, and this is an important point. So when you look at what the EPA and when you look at other regulatory bodies globally, they want to drive the industry to utilize these. And they're going to do it through regulations like AIM Act and what we've seen in California. For those retailers operating in California, remember, keep in mind the date 2030, 1,400 GWP or less average chain GWP, or 55% reduction in GHG from your 2019 baseline. AIM is going to create challenges in the market for higher GWP HFC products as they phase down progressives. This is going to be an important note, especially if you have a heavy install base of 404 or other higher GWP products. Retrofits and new solutions are going to be available to enable an orderly phase down, right? So when we look at that chart, that phase down is fixed. If the demand for those higher GWP products remains consistent, it's going to create challenges for everybody. Chemours is well positioned to be your partner, above and beyond being a domestic supplier of these products and supporting the market and being invested in commercial refrigeration heavily, as you guys have seen over the last several years. We're also going to be a strong technology partner as we move into the next generation products. So we want to hear your questions. We want you to be able to come and work with us as you're thinking through what your plans are going to be for tomorrow. Speaking of the support that we can offer, there's a couple points that I like to highlight here. Number one, product quality. It's constantly overlooked, especially in the refrigerants market. It's not that physical piece that you're holding in your hand, right? All of our products are blended up to AHRI 700 standards. There have been a couple instances in my life when I was working back in the field where you have poor product quality, non-condensables in the can that go into the system, and it creates a lot of headaches and issues. So pay attention to the product quality that you're getting and look for those reputable suppliers. We have a strong local availability network for these products, right? So if you are operating a supermarket either nationally or regionally, you need to ensure that you have a strong distribution network. And through our partners, we're very confident that we can provide the support that you need. We make field support available through our tech line. If you have questions while you're doing retrofits, if you need to walk through a specific step, if you have questions about seals, oils, things like this, we make resources available to address those for you, as well as engineering support when you're looking at next generation solutions. As Andrew had noted, training is going to be an important piece of what we're doing, right? Contractors need to have a lot of training today with all of the different technology that's going on, and it's no different for refrigerants. But when it comes to refrigerants, it comes to employee safety, and it comes to best practice for using these products. And then lastly, regulatory and technology insights. You don't need to wait for the next supermarket news webinar that we're on here to receive an update. If you have questions about your specific situation, we are here to support those questions and to help you as you navigate through this. Now, in terms of resources, I've linked a couple items back here that I feel are valuable that we've had positive feedback on. So number one, we do have a calculator, an online calculator available to the marketplace. It's a free to use tool that allows you to go in and actually plug in your store format, the systems that you're using today, and what refrigerants are installed. It also allows you to do scenario testing. So if you're looking at retrofitting locations, if you're looking at changing architectures, if you're looking at reducing charge, it allows you to go in and plug your existing install base, make modifications to that based on plans that you're looking at, and it will help by providing what that GWP number is going to look like after those changes are made, as well as the GHG number. So it's a quick, simple tool to enable you to go through, look at some of those CARB regulations specifically, understand what's happening, plug in your store format, and start outputting physical values that are going to be important as we start approaching that 2030 date. Additionally, we make several resources available on our website. We have several team members who work on the regulatory side who are constantly taking these bills and trying to digest them into simple slides like we are seeing here today. When you look at the AIM Act, it's about 800 pages. Not a lot of people have time to be able to go through that. So we do make one-pagers available that you can share with other people inside of your company. They're posted on our website, and I have them linked here for convenience. So after the webinar, we'll be sure to send a copy of these slides out so you can jump right into those pages. Back to what I was noting before, we want to hear from you. Our tech-to-tech line is always available, and we're looking to answer your questions. And this was really designed to help contractors as they're going through and performing these retrofits, ensure that they're hitting all of the correct specs, changing all the correct things to ensure quality of work at your location. And then always feel free to follow us. We're very present on YouTube, Twitter, and LinkedIn. We do try to put out a lot of information on there as it's a very simple way for us to communicate quickly. So if you're active on one of those platforms, don't hesitate to add us. We're consistently putting out new content and updates for the marketplace, and we'd be more than happy to have you on there. Now, we wanted to leave some opportunity here to jump into a Q&A. So I think we can get started with that now if we're ready. So the first question that I have up here, and I'll be triaging to the rest of the team, wanted to address a question that came in around 513. So Andrew, for 513A, can 513A cover an entire range of medium temperature applications?
Hey, Brandon. Yeah. So with 513A, if you look at that refrigerant and really how it's being studied, it is looked at in more than medium temp refrigeration. So we're seeing a lot of interest in 513A in applications such as ice rinks. And then there's also, when you talk about some of the new architectures that are being studied, one of them is really a booster using 513A as the low temperature and the medium temperature fluid. Roughly, you can get to coil temperatures of about -20 F with positive pressure using 513A. So it's a little bit lower than, say, 134A could go. But it's definitely not as low as, say, like a 449A or some of the A2Ls we talked about, such as XL20, XL40.
No, thank you very much for that, Andrew. So we have another one coming in here that I think I can tackle. So the source for the TCO study that we were showing before, the performance differences in terms of overall cost and emissions for different architectures. So the third-party entity that we worked with on that in Europe is known as Wave Refrigeration. They are a technology group that worked with us as well as other end users to collect data and to start processing that data to create those charts. There is a full copy of that study available on our website. So if you go to opteon.com, Wave study, you'll be able to pull it up very quickly and review the entire study cover to cover. Additionally, if you do have additional questions about that study, please don't hesitate to reach out to us directly. Okay. So another question that we have here, Andrew. So can 454B be used in equipment that's already using 410A?
No, that's a good question. And I think we focused a lot in this conversation on the ComRef side, but AC is going through changes as well. So 454B is going to be for new equipment. Since it is an A2L refrigerant, it is not going to be a retrofit gas for 410A.
Thank you very much, Andrew. Appreciate that.
Mm-hmm.
So we have a question coming in here about availability out in Utah. So yes, we do have distribution partners in Utah. Please feel free to contact us, and more than happy to work with you on your existing locations that you have problems with. And we'll be sure to send our contact information on the follow-up email that goes out after this call. So more than happy to work with you and point you in the right direction as to where you can secure those products. All right, next question is coming in here. So, Andrew, back to you on this one. Capacity differences between 404A and 449A.
404A and 449A, I would think if you were looking at it at the same conditions, it would be roughly equivalent capacity, probably plus or minus 3 or 4% or so. One of the things that's important to note with 449A, especially when rating equipment for 449A, when you are used to rating equipment with 404A, is that 449A does have a temperature glide. So with the slight temperature glide of 449A, it really is important to understand the temperatures that correspond to the rating condition you're using. If you rate equipment based on dew point for a refrigerant with temperature glide, really the calculations, especially for like condensing units, will typically show that you might need to upsize your condenser. However, when looking at it on when you account for the glide in those calculations, you will see that the capacity between 404A and 449A is pretty similar.
Great, thank you very much for that. So we have a question coming in around energy efficiency when converting from 404 to XP40 or 449A. So I think I can hit the first part of this one. So there are definitely several studies out there and white papers that have been completed over the last several years. In terms of energy savings, it varies, right? In some applications, we've seen it as low as 5%, and others we've seen it as high as 12%. So it really depends on the specific conditions that you're working in, as well as the architecture of the system that you're using, because some of those differences, especially when you talk about other pieces of that system, right, compression technology, things like this, can impact the energy efficiency. So, Andrew, we have another question coming in about the performance differences between 407H and 449. Do you want to provide some comments around that?
Sure. Yeah, 407H is one of the refrigerants we've been getting a couple questions on recently. So if you look at the differences between them, I'd say really two things come to mind. 407H does have a elevated discharge temperature compared to 449. So that is one of the things that I think needs to be considered when working with that fluid. And then also as a retrofit gas, I think if you're looking at things like mass flows and suction pressures, especially for 404A retrofits, and what Mitch was covering before was really important with the 404A retrofits, there's going to need to be a lot of attention towards the TXVs. And if you look at, say, the technical differences between 407H and a 449, I would say 449 is going to be a closer match to really the 404A loading on the valves.
No, thank you very much for that, Andrew. I appreciate it greatly. And again, if you do have a specific instance where you're evaluating a couple different retrofit solutions, if you're looking at, 449, 407. Everything should be done on a case-to-case basis just to give you as real of numbers as you can get based on your situation. So again, please don't hesitate to reach out and contact us. We're more than happy to do some cycle calcs and prepare some information to help you as you go through that process. All right, the next one that we have coming in here. So is 449 more expensive than 404A? So last time I checked counter prices, 404A is more expensive than 449. So right now, I would say that that's probably going to continue to remain true, especially looking at AIM and the GWP value differences between those working fluids. So I would expect that that's going to hold on as we move through the next several years. Okay, so another question that we have coming in. 448 versus 449. I think I can address the first part of this one here. So yeah, 448 and 449 are very comparable solutions. There are differences in terms of what components are used in them. Operationally speaking, there's only minor differences between them, and we traditionally would evaluate those on a case-by-case basis. Great. So the next one that we have, Andrew, so access to updated PT charts and line sizing information.
No, that's a very good question. So we post on our website, opteon.com, you can really go to a specific page for a specific refrigerant. And on that page, you can find all the thermo properties, the retrofit guidelines, PT charts, line sizing. And if it's not on there, it is something that's probably on our to-do list to put on there as soon as possible. So yeah, I know we have updated all the line sizing charts for the A2Ls and the A1s. PT charts will be on there, retrofit guidelines. Anything you need from an engineering perspective, we make sure to put on the website.
Yeah, definitely. I'll also take the opportunity to throw a pitch out there for Chemours Refrigerant Expert. So if you're on Google and you type in Chemours Refrigerant Expert, you can actually download a free tool that gives you access to PT charts, line sizing, and you can play around with a few different scenarios if you're evaluating a retrofit in real time versus the traditional sizing tables. So don't hesitate to download a copy of that tool. Once you download it, it sends you an email with the instructions on how to go through that tool. And as noted previously, if you do have questions on the tool itself, don't hesitate to reach out. More than happy to set up a training and walk you through that platform. So we had another one come in here. So difference between XP40 and XL40. So I'll take the first half here on that, Andrew. So when you look at XP40, that is going to be an A1 solution. So that's R449A. And when you look at XL40, that is going to be a low GWP next generation A2L. So the primary delineation between the both of those is the safety classification. Although close in performance, they do have that difference in safety classification. So XP40 would traditionally be for retrofits versus an XL40, which would be for new equipment. All right, so thank you very much for all the questions. I do see that we have a few more here in the chat. We will definitely get a copy of these questions and we can follow up with you offline. Additionally, if you were not able to get a question into the chat or if you have some follow-up questions after the call, please don't hesitate to contact us. I'll ensure that our contact info is sent out on the follow-up email after the webinar. So thank you very much for attending today. We appreciate your time, and we look forward to following up with all of you very soon. So have a good rest of the day. Thank you.
Thanks, Brandon. Thanks, Mitch and Andrew, for joining us today. I'd like to thank all of you in the audience for joining us today also. As I mentioned earlier, this session has been recorded and will be available on demand if you'd like to share this with a colleague. or review any part of it yourself, please be sure to visit supermarketnews.com for news, information, and insights. And don't hesitate to reach out to me, Mike Brown, at Supermarket News at any time. Thanks again.